quickly, we're going to interpret the slope and the y-intercept real quick. So I went out and I collected data on students. I looked at students' homework average and then their test average to see if there's a relationship. So I put homework grades all in L1, test grades all in L2. I found the average homework grade was 50, the standard deviation of 5. The average test grade was 70 with a standard deviation. I looked at the scatter plot, it was straight enough. I plotted the residuals to double check to make sure it was straight enough. And I saw, oh sweet, I can make a linear model. Here's the linear model that came out. Now, the problem with just looking at this generic model is I don't know what it's talking about. So I like to write the model in context, in the context of the problem or the stuff we're talking about. So if we're talking about the length of a gorilla's foot and then how long that gorilla can hang from a tree branch, then I better say something about feet and branch hanging time. That's not what I'm talking about in this problem. I'm talking about homework and tests averages. So in my model, I like to put that in. And this is simply what I mean. I'm trying to see if I can predict test averages, y, from homework. So I'm going to rewrite this quickly like this. My predicted test average is simply 10 plus 1.2 times my homework average. Now it's in kind of context. But this is the beginning of realizing that this formula tells a story of what's kind of happening. Now remember, this model that we just made, this linear model, kind of tells us what's sort of happening. It's wrong. All models are wrong. It'll probably never predict perfectly. This line probably won't hit any points on the scatter plot, but that's okay. It kind of tells us what's sort of happening out there. And it does a little bit of some work for us, which is cool. So let's just see what it will do for us. But before, let's see what kind of story it tells. Well, there are two important numbers here. This guy and this guy. Let's see what story they tell us. This is what the story says. Let's talk with the first guy. We'll talk about our B naught, our BO, our B old, our BO. Now, this old B, what does it tell us? Well, it tells us when there's zero X stuff. So when there's zero homework, this tells us what the model thinks your test average would be. So this tells us, you know that all y-intercepts are the coordinate 0, some b. Okay? So when x is 0, the b value is your y value. So it tells us when homework is 0, so if someone did no homework and had a 0 homework average, I know you're out there. You're out there. Start doing your homework. It tells us what the model thinks your test average would be. So if I put a 0 in here, the model says it should be about 10. So first of all, this is the model saying if you don't do homework, you're going to have a 10 on your test. Sort of. I'm predicting you'll get your test average will be a 10. So that's one part of the story. But the other part of the story is this interpreting the slope, which is often tricky because it's a decimal or it's some number or it looks weird. So what I like to do is pull that slope out and I like to write it, in the change in y over change in x and think about it like this. Ready? I remember the slope was from algebra, change in y over change in x. And this is not a fraction, but I can write it as a fraction like this. 1.2 over 1. Like that trick. Now, I've got it as a fraction, but I want it to tell a story, so I want to put the units in of y and the units in of x. So y, which is here, test grades or test points. So let's say test score or test average, test points, and here would be homework points. Now it tells a little bit of a story. It tells me that for every one homework point average, as your homework average increases by 1 point, your test average increases by 1.2 points. Ooh. So it says for every 1 point increase in your homework, your test average goes up 1.2 points. And you can actually mess with these. Sometimes you get some weird decimal like this. I can actually say, all right, I've got 1.2 over 1. That's the same thing as 12 over 10. So for 12 on test, homework. So for an increase in 10 points on my homework would increase my test about 12. So the model says, and pretty much make sure when you interpret this, that on average, this is how you do it. Say, on average, the model says that for every 1 point, your homework average goes up. It predicts that your test average will go up 1.2 points. So do your homework. But that's how you kind of interpret what the slope is. I generally have to remember what's y, what's x. I look at it like this. Y is test, homework. So if I made a slope like this, you know it would be test and homework. Change in test over change in homework. I put it over 1. I take whatever the decimal is, put it over 1. I say for every 1 homework point, my test average goes up 1.2 points. Now, if it was negative, it would simply be for every 1 increase in homework point, my test average went down 1.2, but in this case, that's not true. So it's always this. If you can always read these things this way, it kind of goes like this. For every one, for an increase of every one of these, there's this change in these, okay? Pretty much that. So for every 1 homework point increase, there's an increase of 1.2 test points. If this was negative, it would be for every 1 increase in homework, there's a decrease in 1.2 test points. And that's kind of how you interpret the slope. So make it tell a story. Remember, these models are cool. And when you were in Algebra 1 and you were asking yourself, when am I ever going to use this? You're using it. Okay, we're actually using algebra. But imagine if you're like, when am I ever going to use this? And your algebra teacher says, well, someday you'll be making predictions using your linear regression. You'll do some linear regression and create a linear model and predict about what, or you'll predict you make some prediction based on some X variable. You'll be like, really? The reason why you asked the question, when am I ever going to use this, is because you just didn't want to do it, okay? But here's when you use it. And tell that to a freshman who's complaining that you actually use it. And that'll help all of us math teachers out. Have a nice day.